So hi everyone, welcome back to another video on the channel. In this video, we are going to discuss our another topic or another problem in our DSS series. We will continue from the last concept that we have learned, that is how to extract the number of divisors and print them using optimal approach and brute force approach. In the optimal approach, we have used square root of n time complexity, and in this video also, we will require the same concept that we have used to solve that particular problem. So if you have not watched that video, I request you to please watch that video from the link in the description so that you can understand this video better. Also, I will try to recap the concepts so that if you have learnt it in the past but have forgotten it, so you will get a quick recap of that. So let's start the video by discussing what's a prime number. I think everyone know what's a prime number. It's basically a number that is divided by only two numbers, or it have only two factors, that is 1 and the number itself. Apart from these two factors, it does not have any other factor that divides it perfectly. So what's our brute force approach? I think it's very simple. We are going to initialize a count variable. Then inside a loop from 1 to n, we will check for every iteration value that the number is divisible by I or not. If it is divisible, then we increment the count variable. Then at last, after the termination of loop, after the loop is run from 1 to n, we check if the count variable is equal to 2 or not, then we return the value according to that. If the count variable is 2, that means it's a prime number because the number has only two factors. That's only possible if it's a prime number. But if it's having more than two factors, then the count variable will be definitely more than 2 and false value will be returned. So this is basically a ternary operator which returns the value or on the basis of some specified condition. So the time complexity is very simple. It's going to be big O of n because we are traversing the array from 1 to n. So that makes our time complexity big O of n. So I'm going to solve this problem uh, using the brute force approach first so that you can understand what's actually we need to do here. So I initialized a count variable, then I have to initialize a for loop uh, in which we will traverse from 1 to n, both 1 and n inclusive. And then we have to check if n is divisible by I, then we have to increment the count variable by count plus plus, and then we have to return uh, count is equal to 2. It's basically a ternary operator. Don't get confused by it. If you are confused, then please use if and else blocks. That's also works absolutely fine. So let me check for this particular piece of code. That's also a brute force approach. So the test cases have been passed, and let me hit the compile button and check if our test cases have been passed successfully. As you can see, it is giving a error that our time limit is being exceeded. Expected time limit is 1.11 and the code is taking more time than that. And if you go here and check the expected complexity of the code, then it says that square root of n. That means we have to solve this problem in square root of n time complexity. How can we do that? We can do that by this approach that we have learned in the previous video. To extract the divisors of a number, we don't have to traverse the whole numbers from 1 to that given number. We already saw that until the square root of the number, we get all the divisors of a number for the first time. Then after the square root of a number is passed, then we again get the same set of divisors of the number in reverse order. So as you can see here is 36 is a number. We have to extract the uh, what you can say, we have to extract the divisors of the number 36. How can we do that? We will just do one thing. We will extract I, which is nothing but the divisors of one of the divisor of n. N is 36, and we will also extract n by I. Here, n by I is nothing but 36 by 1, which is also a divisor of the number. So we have to extract that. Then we have 2, then 36 by 2, 18. 18 is also a divisor. So in each iteration, we are getting two of our factors. Instead of running the iterations from 1 to n to extract all the factors separately, we can extract two variables or the two factors in one single iteration by using I and n minus I. If I is divisible by n, then n by I is also divisible by n. And after the square root of the number is passed, here the square root is 6, 36 square root is 6. After the square root is passed, we get the same set of divisors in reverse order. So that's our concept that we are going to use in the prime number case. So here we have count variable. Of course, we need a count variable to keep track of the uh, how many variables or the factors we have encountered. Then if n percentile I is equal to 0, then the count variable will be incremented. And if the n by I is not is equal to I, then also count variable is incremented. Here n by I not is equal to I is a edge case to avoid printing the square root twice, because as you can see in this case, we have to take 6 as the divisor of the number. But as you can see, n by I is also 6. So in order to avoid printing or taking the value of the divisor 6 twice, so we have to consider the edge case that we have to print n by I only if I is not is equal to n by I. But in prime number, we don't have to do any of those things. We can just check for the divisibility of the number. If n percentile I is divisible by 0, we will run the loop from 2 to square root of n, so that we don't have to consider 1, because as we know 1 is divisible by every number, so we don't have to check for that. We will run the loop from 2 to square root of n, and in any case the number is divisible by the iteration value, then we get the result that our number is not a prime number. Let me show you the code. Int, no, we don't need a count variable over here. We just have to run a for loop over one from I is equal to, sorry, we have to run from I is equal to 2 until I is equal to math.sqrt. We have to use the math.sqrt function, uh, I plus plus. At any case, we get the divisible uh, or the at any case we get our number divisible by any of the iteration value, then we return false, because we are checking from 2 to the number. So we don't have to, we are checking from 2 to the square root of the number. So in any case, any of the middle numbers is getting perfectly divided by the number, then we know that it's not a prime number. Then at last, if nothing is returned, then that means the iterations have been passed successfully without returning the false value. That means our function or the method or the given number is a prime number which does not satisfy this if block for any of the given value of I. So that makes our complexity of this code square root of n, which makes it more optimal than that of the previous brute force approach. As you can see, the solution is accepted, and hope you liked this video. And if you have any doubts, you can reach me in the comments. I will be happy to answer your questions. Till then, keep learning. Thank you.